2.3, example 6c, we're trying to determine if these functions were what? Even, odd, or neither. So just to review, a function that is even, tell me about it. What are we looking for? Okay, if f of negative x equals the same as f of positive x, then that function will have what type of symmetry? I heard it over here. Y-axis symmetry. Good. So an even function has y-axis symmetry. That means a positive x and a negative x are going to have the same output. And an odd function is what type of symmetry? Origin. And what is another way to describe origin symmetry? Rotate it 180 degrees around the origin. Put your finger down at the origin, spin it. Not 360 degrees, right? Because any graph, then, if you spin it 360 degrees, might be a little dizzy, but it should be the same, right? Yeah. When Jason Kidd was first drafted by the Dallas Mavericks, they were interviewing him, and they said, what kind of impact are you going to have on the team? He says, well, I plan on helping turn around the team 360 degrees. And I was just like, okay, all right, so we're still going in the same direction. Yeah, so anyway, there's a big difference between 180 and 360. Neither, then, would be a what? A function that has neither symmetry will be neither even nor odd. Okay, cool. So we are testing this one out here. We are on part C. Verify graphically. All right, so let's do the algebraic test first. We have h of x is 2x cubed minus 3. Remember that the way that we start the test for even and odd is the same in both cases, yes? And that is to what? Replace x with what? Yeah, the test is to replace x with negative x. So again, parentheses are your best friend. So instead of 2x cubed minus 3, I'm going to go 2 parentheses cubed minus 3. That's simply replacing x with the parentheses. And what do I plug into the parentheses? Negative x. Now I can work straight down. Once you substitute in, you simplify. If I take negative x and cube it, what's going to happen with the negative? Is it going to stay or is it going to go now? It's going to stay. So that I can pull up front and say negative 2x cubed minus 3. Now once you simplify that, you ask yourself, is that the same as the function I started with? No. So that's not equal to h of x. And if it's not equal to what I started with, therefore it's not going to be what? It's not going to be even. But it still could be odd. So the way we determine then if it's possibly odd is we factor out a negative from the entire thing. And that's what we're doing at the end of class yesterday. That becomes negative quantity 2x cubed plus 3. Now because I have a negative out front, I ask myself now, is this thing inside the parentheses the same thing that I started with? Because if it were exactly the same in the parentheses now, I'd have the opposite of what I started with. Is this the same as that? No. So this is not equal to the opposite of h of x, which means it's not odd. And so if it's not even and it's not odd, this would be neither. So h of x is neither even nor odd. Now let's go back and see if we can come up with some shortcut criteria here. We only had one variable, right? And it was the x. It was raised to 3, the third power, which is what type of number, even or odd? Odd. So you might think, if it has an odd exponent, it might be an odd function. But remember, for an odd function, we need to be able to plug in a negative x and get the opposite of what we started with, which means for every term that we have, we would need all the signs to change. Was there any way to change the sign of the negative 3? No. So if you have a polynomial or something with multiple terms, of course, to be an even function, what would we want to have happen? Would we want anything to change? No. For an even function, when I plug in a negative, everything should stay the same. So none of the signs can change. So notice a constant is not going to mess up the fact that something's an even function, because it's constant, it doesn't change. But a constant messes up an odd function, doesn't it? Because to be an odd function, we need all the signs to change. And if 3 is not going to change, it's not going to work. So let's go ahead and summarize that real quickly. For an even function, whenever you have multiple terms, you want no terms, signs to change. That's plural possessive. Terms, signs to change. If it's an odd function, you want all the terms, signs to change. So that's a quick way to do it without actually going through the actual argument. Now, I will expect you on a quiz to go through the formula argument, but in the future, we're going to be using symmetry to kind of help us think about what the function looks like. And we can determine that very quickly. So let's go back through ABC and just use this criteria now and see if it works. All right, on A, I have two terms. If I plug in a negative x, here, squaring it is going to get rid of the negative. So this one's not going to change because it's raised to an even power. Is 5 going to change? No, it's a constant. So no change in the first term, no change in the second term. Therefore, it must be what? Even, right? So constants don't mess up the fact that it's an even function. In this one, notice because the first term is squared, there's not going to be a sign change there, right? When you square a negative, it goes away. But the second one is raised to the first power, which will keep the negative, right? If you raise a negative to an odd number's power, it's going to be a negative number, so it'll change the sign. So the first sign stays the same, the second sign changes. Now, as soon as you have mixed, if one term changes signs but the next term doesn't, guess what? It's game over. The function has no symmetry. Okay? They either all have to stay the same to be even, they all have to change to be odd. If you have a combination, it's going to be neither, and that's what we said at the end of class yesterday. So looking at this one from that perspective, the first term has a variable, but it's to an odd power, so that one's going to change. Maybe you denote that with an x. The constant is a constant. It's not going to change. So now we have the first one changing, the second one not changing. Game over, no symmetry. Okay, let's do this one like that. But let's think about what the answer should be first, and then we'll come back and justify with the formal argument. My function's name is v. The independent variable is t now instead of x. I have two terms. They both have variables. What's the exponent on the first variable? It's odd. So will that sign change? Yes, that sign will change. On the second one, what's the exponent? I got it, Sienna. It's odd. Will that sign change? Yes. All done? Awesome. Thank you. So we have two terms. When I plug in a negative t for t, both signs change. So based upon the criteria we've established, that should be what? Odd. This should be an odd function because all the terms in the expression change signs. Now let's see why. The test would look like this. This is kind of the formal argument. You replace t with negative t. So I'm going to have negative 1/2 blob cubed minus blob. I just put parentheses. And now I'm coming back and in place of the t, I'm putting negative t, negative t. And I will simplify. So negative t cubed is negative t cubed. And I can multiply the negative that I get there times the negative in front, which makes it positive t cubed, 1/2 t cubed. And a negative times the negative here is a positive. Now notice that is not the same as what we started. That is not v of t, so it's not going to be even. But if I were to factor out a negative from each term, I would change their signs, and I would end up with negative 1/2 t cubed minus t, and now this is what I started with, and so that is actually the opposite of what I started with, and so now I have the argument v of negative t equals negative v of t, so v of t is odd, and has what type of symmetry? Origin, rotational symmetry. Good. So that would be the formal argument there. Okay, so what's that? My favorite type of symmetry is bilateral symmetry, which is kind of a universal y-axis symmetry for any vertical line. We humans have bilateral symmetry. There's like a y-axis that runs right down our forehead, through our nose, across our lips, across our chin, down our, oh yeah, okay. And so most people, if you folded them along that line, would coincide. You know, give or take a freckle on this side and not one over here. Thanks for asking. Yes?
Do you want us to show the last two steps, or can we just solve and see that it's the opposite?
No, there's going to, on the quiz or the test, I'm going to ask you to give a formal argument for is something even or odd. And this is what we would need to see. But once we get beyond that, then I'm just going to allow you to say, oh, both signs change, it's odd. Okay? Good question. So we do have to know the formal argument. If we never learn the formal argument, never practice the formal argument, we can't do it if we're expected to. But if we know how to do it, we know how to not use it when we don't have to, right? That's right. Okay, now they get more interesting because now we have ratios of two expressions. Oh. Yeah. Yeah, I have something divided by something. That's a ratio. Yeah, I have a ratio of two expressions. Or I have some expression divided by another expression. Let's go ahead and do the actual test before we come up with any rules of thumb. The test then requires us to replace our independent variable, in this case m, with negative m. And over here I get negative m quantity cubed over 3 minus 2 times negative m quantity squared. Your exponents always go outside the parentheses because the first step really could be to replace the variable with parentheses. So that would be the first step. Questions on that? Now I'm going to simplify. In the top, negative m cubed, is that going to become positive m cubed or negative times m cubed? Does the negative stay or go? It stays, so that's negative m cubed. In the bottom, I get 3 minus 2 negative m quantity squared. Does the m stay or the negative stay or go? It goes, so it's just the same as positive m squared. Okay, now you ask yourself, is this the same as what we started with? It doesn't appear to be the same as what we started with, so this appears to not equal r of m, and therefore it appears to not be what, even or odd? Even. But could it still be the opposite of what we started with? Yeah, now here if you have a ratio, you want to be careful. The denominator looks like it's ready to go, like it's the exact same, yeah? It just looks like the numerator is the opposite. Now, before I do anything with the negative, let me just kind of review. If I have the number negative 1/2, right, the negative can be out in front of the division bar, right? And that means the entire ratio is negative. But I can also call that negative 1 over 2, yeah? Which should be the same as 1 over negative 2. Is that the same? Good. If you have a ratio and it's negative, then either the top or the bottom, but not both, is a negative number, right? Okay. So notice I have that negative floating in the top. I can actually pull that negative, just like we did with the numbers, I can pull it out front of the entire expression. Now, because it's out in front of the entire expression, that's the same thing as negative 1 times the whole thing. So now I can put parentheses there without any loss of generality. Now that I have a negative in front of something in a parentheses, now I can ask myself if what's left inside is the same as what I started with. Is it? Yes. So this now becomes the opposite of r of m, which means that r of m is what? Is odd. You don't factor a negative out of the top and bottom if you just want to factor a negative out. If you want to factor a negative out, you factor it out of either the numerator or the denominator. But if you factor a negative out of the top and bottom, you're factoring out a positive 1. Because what's negative 1 divided by negative 1? Positive 1. Okay, now we don't have enough experience to come up with a rule of thumb yet, so we're just like, okay. Got it. Let's move on. Try it again. Q of z, what's with all the funky letters? Well, f of x gets boring, doesn't it? You like it. I like it too, but it does get boring. Like peanut butter and jelly. I like it, but it gets boring. If there were only something else we can put on instead of jelly. Mayo. Or marshmallow fluff. That's different than marshmallow, because marshmallow fluff is just like the liquid marshmallow that comes in the jar. You spread it on the peanut butter, and you get a what type of sandwich, Celeste? Fluffernutter. Do they have Fluffernutter flavor at the McDonald's McCafe? Yeah. That's it? Okay, good. Way to celebrate. Okay, is this even, odd, or neither? Yeah, that's what I say. Let's just work it out. The test is you replace the independent variable, in this case z, with negative z. And we have how many different places in this expression to replace z with negative z? 3 in the top, 2 in the bottom. That's 5. Okay, here we go. So 3 parentheses, negative z to the 5th, minus 6 parentheses, negative z to the 3rd, plus parentheses, negative z. In the bottom, 3 parentheses negative z cubed plus 4 parentheses negative z. Okay, so I replaced everything with negative z. Now I got to go through and simplify. The question in every single term is, does the negative stay or does it go? So in the what happens to the negative in the top in all three terms? Does it stay or go? It stays, because what type of exponent do we have in the top? They're odds, okay? So that's going to be a negative 3z to the 5th plus 6z cubed minus z. All the signs changed in the top. All the signs changed in the top, right? So if we were just looking at that function and that function alone, we could say it's what? Even, odd, or neither. The numerator is an odd function. But we have a denominator also. Now, what are the exponents in the two variables there? Even or odd numbers? They're also odd. So both of those signs will also change. That's going to be a negative 3z cubed and a negative 4z. So the denominator itself is even, odd, or neither? Odd. So what we have now is essentially an odd function divided by an odd function. You think it's even? You think odd divided by odd is even? Based on what criteria? Yeah, keep going. They divide. Yes, that's exactly right. All the negatives that you factor out will divide out. So let's go ahead and do that. If I this is, first of all, not what we started with. And if I just factored a negative out of the numerator to see if it was the opposite of what I started with, then the denominator is not going to match up either. So in this case, to get the numerator and the denominator to match, I need to factor a negative out of both top and bottom. So that's going to be a negative 3z to the 5th minus 6z cubed plus z. All over factor a negative out of the bottom, I get a z3 cubed plus 4z. And notice what's left here that I'm highlighting? That is the exact same thing that I started with at the top, yes? But now what do I do with the negative that I factored out in the top and bottom? Well, that's really a negative 1 divided by a negative 1 times all of this, which I'll just copy and paste because I can. And Kevin, what happens to negative 1 divided by negative 1? They divide out, giving me a 1. Yes. So if you ever factor a negative out of the top and bottom, as I kind of already mentioned, you're going to end up with a positive 1, essentially. And now we end up with really the exact same thing that we started with. So this ends up being q of z. So q of z is what? Even, odd, or neither? It's even. If you look at the logical consequence, we've got q of negative z equals q of z. So plugging in a negative z and a positive z gives you the same thing. So q of z is even. So apparently, an odd divided by an odd is an even function. An odd divided by an odd is an even function. You think that's always true? Yes, because it's the same argument if you do it with variables. You're going to have an odd function in the top, meaning you can factor out a negative. You're going to have an odd function in the bottom, which means you're going to factor out a negative. Those two negatives will always divide out to give you what you started with. So this is important to remember. An odd divided by an odd is an even function. Let's retreat over here to the previous problem and kind of look at the same thing. If we just looked at the numerator of this one, m cubed, the numerator was what? Even, odd, or neither? It was an odd function. And the denominator, 3 minus 2m squared, was what? Even. We determined that this one was an odd function. What do you think an odd divided by an even is going to be? It's going to be an odd. Huh? So an odd divided by an even is going to be an odd function. What do you think an even function divided by an odd function is? You think it's going to be odd as well? And again, I'm using all caps versus no all caps for no particular reason. Yeah, and even over odd should be odd because if you just imagine, reciprocating this expression, R of m's expression, you're going to get the same thing. You're just going to be factoring the negative out of the other side of the fraction. So yeah, an odd over an even is an odd. An even over an odd is an odd. An odd over an odd is an even. What do you think an even over an even would be? You think an even over an even is an even function? Well, I think that you're probably going to be right. Yeah. You want to prove that? Let's prove that. Let's prove that. I'll show you how to prove that an even over an even is an even function. Let h of x be even. Oops. Such that, okay, if it's an even function, such that h of negative x is equal to h of x, right? That's what it means to be even. And let's also define this new function g of x to be even, such that, I forgot the word that, I'll squeeze it in here, such that g of negative x equals g of x, right? That's what it means to be an even function. So now let's define this function f of x to be h of x over g of x. Are you okay with that? Let's go ahead and do the test now on f of x. So what we have in f of x is a quotient of two even functions. And y'all said that it's supposed to come out to be an even function. We shall see. The test is to replace x with negative x. And so I get h of negative x all over g of negative x. Now if I simplify the top, because I know h of x is even, what is h of negative x equal to? H of x. Yeah. And because g of x is even, what's g of negative x? G of x. Now I ended up with h over g. Is that what I started with? Yeah, so that's equal to f of x. So what did I prove here without doing anything with actual expressions? I proved that f of negative x equals f of x if f of x is a quotient of two even functions. So f must be even. So y'all got it. Y'all's intuition proved correct. All right, so that's pretty awesome. We're going to summarize down below. So if you wanted to kind of memorize this, you can think of even functions as being what type of number? Where else have you seen this, where an odd over an even is odd, or an even over an odd is odd? Odd over odd is an even. Positives and negatives. And remember, the fact that it's even and odd is kind of like a positive and negative. So you think of an odd function as being what? A negative or a positive? A negative, right? And an even function as being a positive, because what's a negative divided by a positive? A negative. What's a positive over a negative? A negative. What's a positive over a positive? Positive. That's even over even. And of course, the good one over here on example F, what's a negative over a negative? Positive. So when you have ratios or quotients of two expressions, you could do it this way. Just figure out if the top is even or odd, bottom is even or odd, and then kind of rely back on negative numbers. Let's use that right here. Let's not actually do the argument. I'm not going to have you do the argument for ratios, just for real simple things. This is how we're going to do it in the future. Is the top even, odd, or neither? It's neither. Because this sign will change, this sign will change because they're both odd exponents, but will the 6 sign change? No. And so anytime you have multiple terms, some changing, some not, it's game over. So now I have a neither divided by, is this function in the bottom even or odd? That's an even function. 3x squared plus 4 is even. The first term is not going to change because it's squared, and of course the second term won't change because it's a constant. Now what do you think a neither divided by an even is? Neither. What do you think an even divided by a neither is? Neither. What do you think an odd divided by a neither is? Neither. What about a neither divided by an odd? Neither. What about a neither divided by a neither? Neither. Oh my gosh. You know who you don't want to invite to your fluffernutter party? Neither. They are party poopers.
Would neither technically be like 0?
I guess you want to think of positive and negatives. You could think of neither as being a 0, and it kind of just wipes out everything. You can't divide by 0, but 0 divided by anything is 0, which is neither positive or negative. Sure, you could think of neither as being 0. I like that. Neither wipes out everything. You get one neither in a ratio, and the whole thing goes to neither. Bummer. Okay, so that ends it for the ratios. But we're going to have other fun types of problems, right? Something like this. And this always gets people on quizzes. Did you hear what I just said? This always gets people on quizzes. Are you going to let it get you? No. Heck no. Are you going to take the quiz? Yes, because that's one way to avoid letting it get you on the quiz. I'm not taking the quiz. I'm not going to let it get me. I'm avoiding the quiz altogether. Well, we're not going to do that. We're going to take the quiz, but we're going to get it right. Let's go ahead and do the actual test, right? The actual test is to replace x with negative x. Okay, so I got negative 3 cube root of, under the radical, I have 8 parentheses negative x. All right, so now we're going to simplify under the radical. What is 8 times negative x? Negative 8x. Very good. Now, is that the same that I started with? No. It's not the same. So it's probably not going to be even. But could it still be odd? Possibly. Let's see. Not necessarily. If it's a ratio, you got to be careful. Because look over here. When I started with this, I said that that was not the same as what we started with. But you can't say that it's not even yet, because when you factored out a negative from the top and bottom, it did end up being even. So you don't want to exclude that it's not, but you want to say it's probably not going to be even. Let's see if it's odd. In other words, let's see if we can get this to look like this piece right here, and we'll see what the sign out front is. So it involves trying to work with the negative under the radical. Oops. Now, if this is a cube root, are we allowed to have negatives under the radical? No. Yes. If this, we can take the cube root of a negative number. We can't take the square root of a negative number. So let's go ahead and split that up. Let's say that that's the cube root of, and I'm going to split up those factors. This is the cube root of negative 1 times 8x. Yes, yes? Are you okay with that? Is negative 1 times 8x negative 8x? Yep, nothing up my sleeves, right? Nothing up my sleeves. No sleight of hand. It's just legitimate math. Now, because they're multiplied, I can give them their own radical. Yes, yes? Yes, yes. Because they're factors, I can do that, because that's really the rules of exponents. Now I can evaluate this. What is the cube root of negative 1? That is, what number times itself 3 times gives you negative 1? Negative 1. So I end up with negative 3 times negative 1 times the cube root of 8x. And what's negative 3 times negative 1? Positive 3. So I simplified it down to that. Now let's do our analysis again. Is this the same as what we started with? No. Okay, it's not. So now I'm going to say it's not going to equal f of x, so it's not even. But is it the opposite of what we started with? Yes, we started with a negative 3 times that, and now we have a positive 3 times that. So this does equal the opposite of f of x. So f of x is odd. It has origin symmetry. It was one term, and the sign out front is the opposite of what it started with. So if you only have one term, you only need that first term to change signs in order to be odd, right? If you have multiple terms, you need all the terms to change to be odd. You're picking up on that? Good. Letter I. TD. Touchdown. TD. T of D, not TD. That's a different cheer. T of D. My favorite function. T of D. Fluff for nutter. I don't write cheers. I don't know if you know that. No one pays me to write cheers for them. Okay, you do. On the count of 3. 1, 2, 3. You do. Go. Even, odd, or neither. You have a quotient, right? So you can analyze each one independently. And then use your little trick, even over odd over even, odd over odd, so on, so forth, etc., etc. This would be the boring part of the video if you're watching at home, where you're actually trying this on your own. Listening to music in the background, perhaps. I have a charger temporarily that you can borrow for the next 5 minutes. Is that, or you need to borrow for the rest of the day? Yeah, okay, yeah. I mean, a little juice is better than no juice. You might want to become a wall hugger now, though. There you go. There you go. See, that's kindness right there. All right, if you're watching at home and you want the details of what just happened, just email me. Right now they're staring at this screen. Yeah, they're just, this is what they see. And they're just like, they're trying it. Hopefully you're trying it on your own, right? You're trying it on your own. And you're not letting all this other stuff that's happening that you can't see distract you. You just got your head down and you're focused. Math requires focus. So me talking while y'all are working is similar to what the drum line did to the band, right? At the beginning of the year when they're trying to keep a certain tempo, the drum line plays a different tempo. Did y'all do that? Or was that last year? You try to deliberately throw off the cadence so the band is forced to focus on the metronome instead of the drums. Did y'all do that this year? I know y'all did it last year. Yeah, at the very beginning of the year, I remember that. No, you don't remember that? I was like, man, that is an awesome concentration activity, right? Okay. Anyone got it? What'd you get? You got that it's an even function. Okay, so we'll take a poll here. Whoops, not with the highlighter though. Anyone else get odd? No one got odd. Okay. I have no idea. I haven't worked it yet. I've been talking about chargers and drums and stuff. Anyone get neither? Anyone else get even? Okay, 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 1, that's 9. Are you impressed? I did that in my head. 8 plus 1 is 9. That's 9 votes for even, and it looks like probably 18 votes for abstaining from voting, which means that the no votes win. All right. Let's see. This is going to be essentially the cube root of d squared. Yes, yes, if you rewrite it? Okay. Now, let's just do it very quickly here. If you replace d with negative d, what's the first thing you're doing? Nothing. No, you're not doing nothing. You're squaring it, which means what happens? Does it change? Does it change? No, it doesn't change the sign. The top stays the same because the first thing you're doing is squaring it. Now, if you wanted to square it outside of the cube root, because you could write it like that as well, no big deal. The square root of a negative number is going to be a negative number. But what are you doing then after that? You're squaring it. So the top sign is not going to change, so the top's going to be even. In the denominator, when you plug in a negative for d, what's the first thing you're doing, Anthony? Squaring it. So does the bottom change? No. What's an even divided by an even? Even. That function has y-axis symmetry. We are done with example 6.